Module 1. Fundamentals of Welding. Lesson 1. Introduction to Welding. Hello folks, I am so excited to have you as a student. Welcome to the first module of this course and the Fundamentals of Welding lecture. Welding is a crucial process in various industries, from construction and automotive to aerospace and manufacturing. It involves joining materials, typically metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool, causing fusion. Welding is a skilled trade that requires an understanding of different techniques, materials, and safety protocols. This lesson will provide an overview of welding processes and applications, as well as important safety procedures. Overview of welding processes and applications. The variety of welding processes used today allows for versatility in industrial applications. Understanding each process's strengths and limitations is essential for choosing the right type for specific tasks. 1. Shielded metal arc welding SMAW. SMAW, also known as stick welding, uses a flux-coated electrode to create an arc between the electrode and the metal workpiece, melting both the electrode and the workpiece to form a weld. It's widely used for its simplicity and effectiveness in outdoor conditions. 2. Gas metal arc welding GMAW, commonly referred to as MIG metal inert gas welding. GMAW uses a continuously fed wire electrode and a shielding gas to protect the weld pool from contamination. It's popular in automotive and manufacturing due to its efficiency and speed. 3. Gas tungsten arc welding GTAW, also known as TIG tungsten inert gas welding. GTAW uses a non-consumable tungsten electrode and a separate filler material. It's ideal for precision work and thin materials, commonly used in aerospace engineering. 4. Flux-cored arc welding FCAW. This method is similar to GMAW but uses a tubular wire filled with flux. FCAW is highly effective for thicker sections and is commonly employed in construction. 5. Submerged arc welding SAW involves forming an arc between a continuously fed electrode and the workpiece beneath a bed of powdered flux. It provides high-quality welds and is extensively used in shipbuilding and pipelines. Applications: construction. Welders are essential in building infrastructure such as bridges and skyscrapers. Automotive industry. Welding is key in assembling vehicles, ensuring structural integrity. Aerospace. Precise welding methods contribute to aircraft fabrication. Manufacturing. Welding processes join metal parts in machinery production. Oil and gas. Pipelines rely heavily on robust welding techniques. Safety protocols and best practices. Ensuring safety during welding operations is paramount. Here are some critical safety protocols and best practices. Personal protective equipment (PPE). Welding helmet protects eyes and face from UV radiation and sparks. Gloves. Insulated gloves prevent burns and protect from electrical shock. Protective clothing. Flame-resistant clothing prevents burns. Respirators, necessary for protection against fumes and gases. Workplace safety. Proper ventilation ensures fumes and gases are effectively dispersed. Fire safety. Keep flammable materials away and have extinguishers ready. Equipment maintenance. Regularly check equipment for safety hazards. Training and awareness. Continuous education on safety protocols enhances overall safety. Environmental considerations. Welding creates fumes and waste that can impact the environment. Implementing waste management practices and minimizing emissions through advanced technologies and proper material disposal can help mitigate these effects. Executive summary. Here's a summary of welding processes and applications. Welding processes. 1. Shielded metal arc welding SMAW, also known as stick welding, uses a consumable electrode covered in flux. 2. Gas metal arc welding GMAW, also known as MIG welding, uses a continuous wire electrode and shielding gas. 3. Gas tungsten arc welding GTAW, also known as TIG welding, uses a non-consumable tungsten electrode and shielding gas. 4. Flux cord arc welding FCAW uses a special electrode that produces a flux to shield the arc. 5. Submerged arc welding saw uses an electrical arc to melt the metal with the arc submerged under a layer of flux. 6. Resistance welding RW uses electrical resistance to heat and join the metal. 7. Laser beam welding LBW uses a high-energy laser beam to melt and join the metal. 8. Electron beam welding EBW uses a focused beam of electrons to melt and join the metal. Applications: 1. Construction, building frames, bridges, and other structures. 2. Automotive, manufacturing and repairing vehicles. 3. Aerospace, building and repairing aircraft and spacecraft. 4. Shipbuilding, building and repairing ships. 5. Piping and tubing, welding pipes and tubes for various industries. 6. Machine repair, repairing and maintaining machinery. 7. Fabrication, creating custom parts and assemblies. 8. Art and sculpture, creating decorative and functional pieces. Industry-specific welding processes. 1. Oil and gas uses specialized welding processes such as GTAW and FCAW for pipeline construction and repair. 2. Aerospace uses high-precision welding processes such as LBW and EBW for aircraft and spacecraft manufacturing. 3. Automotive uses high-speed welding processes such as GMAW and FCAW for vehicle manufacturing. 4. Shipbuilding uses submerged arc welding saw and flux cord arc welding FCAW for ship construction and repair.
Safety considerations. 1. Personal protective equipment (PP), wearing proper PP, such as helmets, gloves, and safety glasses. 2. Ventilation, ensuring proper ventilation to prevent inhalation of fumes and particles. 3. Fire safety, taking precautions to prevent fires and having a fire extinguisher nearby. 4. Electrical safety, following proper electrical safety procedures to prevent shock and electrocution. Here's a summary of safety protocols and best practices for welding and fabrication. Personal protective equipment (PP). 1. Welding helmets, protects eyes and face from UV radiation, sparks, and debris. 2. Safety glasses, provides additional eye protection. 3. Gloves, insulates hands from heat, sparks, and electrical shock. 4. Welding jackets and pants, protects skin from sparks and heat. 5. Steel-toed boots, protects feet from heavy objects and electrical shock. Safety protocols. 1. Pre-welding checks, ensure equipment is in good working condition. 2. Ventilation, provide adequate ventilation to prevent inhalation of fumes. 3. Fire safety, keep fire extinguishers nearby and ensure proper disposal of hot sparks. 4. Electrical safety, follow proper electrical safety procedures to prevent shock and electrocution. 5. Confined space safety, ensure proper ventilation and safety procedures when working in confined spaces. Best practices. 1. Regular equipment maintenance, regularly inspect and maintain equipment to prevent accidents. 2. Proper welding techniques, use proper welding techniques to prevent accidents and ensure quality work. 3. Housekeeping, keep work area clean and organized to prevent tripping hazards and fires. 4. Safety training, provide regular safety training to employees to ensure they are aware of safety protocols and best practices. 5. Emergency preparedness, develop an emergency response plan and ensure employees know what to do in case of an accident.
Hazardous materials handling. 1. Proper storage. Store hazardous materials in designated areas and follow proper storage procedures. 2. Labeling and signage. Properly label and sign hazardous materials to ensure employees are aware of potential hazards. 3. Handling and disposal. Follow proper procedures for handling and disposing of hazardous materials. Regulatory compliance. 1. OSHA regulations. Comply with OSHA regulations and guidelines for welding and fabrication. 2. Local and state regulations. Comply with local and state regulations and guidelines for welding and fabrication. 3. Industry standards. Comply with industry standards and guidelines for welding and fabrication. Here's a summary of welding environmental considerations. Air quality. 1. Fume emissions. Welding processes release fumes containing metals, gases, and particles, which can be hazardous to human health and the environment. 2. Ventilation. Proper ventilation is crucial to remove fumes and particles from the work area, preventing inhalation and environmental contamination. Noise pollution. 1. Noise levels. Welding processes can generate high noise levels, potentially causing hearing damage and environmental disturbance. 2. Noise reduction. Implementing noise reduction measures, such as sound-absorbing materials or personal protective equipment (PPE), can minimize noise pollution. Waste management. 1. Hazardous waste. Welding processes generate hazardous waste, including spent welding rods, fluxes, and cleaning solvents. 2. Proper disposal. Ensure proper disposal of hazardous waste through designated facilities and recycling programs. Energy efficiency. 1. Energy consumption. Welding processes consume significant amounts of energy, contributing to greenhouse gas emissions and environmental impact. 2. Energy-efficient equipment. Implementing energy-efficient welding equipment and processes can reduce energy consumption and minimize environmental impact. Water pollution. 1. Chemical contamination. Welding processes can release chemicals into waterways, contaminating aquatic ecosystems. 2. Proper cleaning. Ensure proper cleaning and disposal of welding equipment and materials to prevent chemical contamination of waterways. Regulatory compliance. 1. Environmental regulations. Familiarize yourself with local, national, and international environmental regulations governing welding practices. 2. Compliance. Ensure compliance with environmental regulations to avoid fines, penalties, and reputational damage. Conclusion. The fundamentals of welding encompass various processes and a strong emphasis on safety. By understanding different welding techniques and adhering to safety protocols, one can ensure efficient and secure welding practices. For further learning, engage with hands-on experiences and continuous education to keep up with technological advancements and improve your skills. Thank you for attending this lesson. We hope to see you again in the next lesson. Happy learning, folks!